So previously we already have the simple definition for discrete event simulation. So right now we will start the discrete event simulation. And later today we have an example. Simulation of a single server queue system. So we don't know we need to have a time, and we have a clock, and the clock needs to allow time to advance. So we have theta and theta. Theta here, I mentioned. Maybe you have a question. Why we know from maybe the initial time instant to know next one. I don't know, maybe we don't have the specific way to check how we know, but we didn't know. Oh, okay, if we have the given possibly events, so you will have time instant associated with the event 1, 2, 3 to the others. If so, it's called the theta, right? Previously I explained this. And for this theta, of course, we have an A. A means arrival. And S means service. So arrival, think about this. We have event 1 is arrival. And event 2 is arrival. And here we have event 1 with the service time. And so that event 3 should be time completed for event 1. So it should be C, completed. So the third event actually is a time completion. So we have a mixture. Arrival, departure. Right, arrival and departure. That's possible. So arrival, departure, that's the nature of a system as well. Because you allow, you will accept the arrival of the customer. And you will serve those customers, and those customers will leave. So we will have the arrival and departures. Well, for the theta, actually, I don't know. We have the events of arrivals, events of departures. And so that you have the next event. And the next event possibly can be the arrivals of a customer or the departure of the customers. Alright, at this moment we have the two possible time instant arrivals and departures. Well, for next event, time advance, of course, you notice initialization. The first one starting from 0. Of course, time of event should be determined. Or otherwise you won't have the idea to apply this data, right? So you will have the stats and the event, so it's okay. So first of all, 0 to first one to next one, and next one. So you can continue until the stopping condition is satisfied. So stop it. And then you can collect the performance measures. Right? So this one says, if you can have the initial setting, then you can go to the next one, then next one. So you can repeat this pattern and until you should stop the observation in the simulation. So this is the theta. And for theta, actually, you should determine the time instant. Sometimes you call it a slot time. That says we have the fixed slot time. Because of theta, so it should be fixed. Fixed slot time, then you will have the time to visit the system. Well, previously I don't know, sometimes you don't think you need to serve, so this one. The first one, yes, we have one customer to serve. And the second one, no. Yes. Right? And yes. And yes. Alright. And maybe for a yes, we have one. And yes, we have two. Yes, we have many. And so how to do? Sure. Because of the way to visit. So you need to follow the possible working mechanism, but you need to finish serving maybe two customers, because if you have 1 and 2, or maybe you just try to check. It doesn't mean serve always. Possibly you need to process for departure. Alright. So just follow the real working mechanism to serve, to allow the customer to depart or something else, and that's it. So it doesn't mean theta then you change the nature of the system. No. You just change the way to check the details of the system. Something like, oh, you have a probing mechanism. Okay, to probe it, okay, you know status 1, and probe again and again. So theta, you visit and so that you know the details of the system. Or maybe you think it's a probing. And probing the status of the system so that you know how to have the further processing. Well, so this is a simple illustration of the theta. Because of theta, so it does not skip over inactive period. So possibly it consumes more time, right? Because you cannot skip some of unnecessary visits. Well, for our simulation, actually, of course, we should have the simulation. And how to have the simulation? Actually, we already have the components here. And this component can then have the discrete event simulation model. And of course, previously we know stat. It's okay. And we know clock. It's okay. And in fact, you know, you want to have the measure. Then you will have the statistic counters. And you will have the initial stats. So, you will have the initialization. And because you need to know the next event, so you want to know, or maybe allow the time routine to let me know. If I finish the current one, so what's the next one? So you will have the timing routine. Alright, to find the time. And find time routine because we have departure, arrival. So you want to know the next departure. You want to know the next arrival. But for us, actually, we want to find the next event. To find the next event, then you will have the event routine. And also, you need to have a program. The program actually should have some necessary library. So you may have a library. Sometimes you don't think so. You just try to have your own function. Then it won't be necessary to have a library. But the other thing, you need to create the function by yourself. Sometimes no. So, of course, if possible, you can have the library. Or maybe, alright, so it's my first time to have the simulation program. So, first time, program 1 with the sum of function. Maybe they are useful. So next time to have the programming assignment, is it possible to reuse the previously defined function? It's possible. So of course, we want to recycle. To have the recycle, of course, we will have the possible library. And once finished, because you observe the system, then you need to have the output or something like the output will be dumped. If you have the dump, then you have the repo generation. And finally, because we based on at least because we based on C programming language. So of course we have a main function. Even for the others, we have a main function. Something like this is the main control, right? So we have the main control, and the main control can, for example, invoke any routine, invoke the other routine, and so that all the function can be controlled by the main program, and so that you can finish some of the mission by the program. Specifically here, we have the simulation program, right? And we have all these. Of course, we don't have any missing items. Even we don't have any missing items. Anyone want to let me know? Okay, yes, we should have the others. If yes, raise your hands, let me know. So any event or any component missing? If yes, raise your hand to let me know, and we can add that component to the current list. No, right? And is it possible to, for example, to delete some of them? The only one should be library. Only these. Only library is optional. The others actually for the current one is Huei-Wen simulation model. Yes, system state required, clock required, static counter required, initialization required. Timing event, because of a discrete event, so timing event, they are required. And because we want to have the measures, of course, we will have a repo generator. And for main program, it's true. So only the library is optional. And why not? I don't explain in detail, but at least they have 2 minutes to have the checking. But before that one, perhaps, let me have sorry. So let me have the groups for you, and then you have the possible members of your group. Group 1. Maybe 4. So and you can rearrange the seats. So rearrange the seats after discussion. 4 members. And good to 4. It's correct. And go 3 here. And group 4, come here. Group 4. Here, group 4. Group 8 here. Group 4. No, here.
Thank you.
Or maybe finally it's fine. Yeah, true. So right now, that we have 3 minutes to discuss the current flow chart or components relationship. Even I don't discuss it directly with you. Feel free, of course, take a picture first. Try to push you to think about this. So 3 minutes for you to have a discussion. Of course, feel free to discuss with your neighbors. And you can check, is it reasonable? Or maybe, okay, everything's okay for you.
Prepare the simulation, then I think like there is then it's basically like we're going down exactly you have the timing and you move down and if it's like over doing like still just like basically like one like that and when it's over it just go down and try to record. Basically, it's the cycle, like, like the type of block, how exactly it's like next, next hour, down, with a bill or just
So let me interrupt And of course, I push you to think about the flow chart or maybe the arrangement for the how to have the simulation components. And let me ask you to think about this main program. Is it necessary to involve an initialization routine within the main program? Yes, controlled by main program. And because the simulation need to be run, so of course we need to involve timing and event, right? And once we know, okay, event, we need to process event I, so go to event I routine. And after initialization, go to initialization, timing and timing. And of course, for the event pathway, we need to relate it to library. And of course, once finished, then we can have a simulation over. And no, then go to the main program again. If yes, then go to the repo generator. And within the repo generator is issue, compute, estimate of interest. And prepare a report, that's correct. And for initialization time, simulation time, set it to 0. And all the state or the counter should be reset. And of course, need to initialize the event list. As for timing, yes. We may have a different time. Determine the next one. And advance. And for next event, okay, choose that one. So of course, we need to process that event. Of course, update the system status, update the statistic counters, and generate future event because the current event finished. The current concept says, yes, we have the general event, but I just focus on the current one. As for the next one, once finished, here. Once finished, then generate the future event, at least one future event, and add to the event list. And here, maybe not one only, possibly maybe, okay, to process this one. So we have the possible future, and maybe this one related to that one. Possibly we have two, but at least one future event. So this is the component of the data approach. Initially, I push you to think about those, but at least after letting know all the details here, you should understand it's natural, right? Okay, right, so if it's okay, then allow you to have one more to check. Any possible question? If no, that's fine. Or maybe, okay, yes, I accept, but one more for you to discuss. Alright, so that's it. And I check, we have the second class string. For the first one, maybe because of a wrong operation, I don't have the recorded video for class 1. It doesn't matter, I think if you ever join, that's okay. Alright, so this is the flow of control of a data approach. It should be okay, right? And later we want to pass on the framework to have the preparation. But after now about the current one, I still want to use this activity to check any possible questions or not. So let me check and try to better have your feedback. About the current flow chart. Any questions from you? If yes, let me know. If no, just type no. So finish? All right. So I will start to collect the activity since week 3. So current week is second week. So still allow you to be familiar with the possible activity, including these. All right, so if no, that's okay. Let me continue.
Please wait. I want to ask about.
Oh, sorry. Let me check.
Sorry.
Let me check. That's okay. Let me check.
I was typing about the question. Sorry.
All right, so if I didn't see these, so your questions?
Why when initializing event list, it won't be generated from DM in the simulation?
So let me check. So you want to check the initialization for the event list, right?
Do I have to send the question to?
It doesn't matter.
Okay.
Sure. Next time you can send this one, right?
Yes. Yes.
For the event list, actually about the arrival, should we have the first one? Yes. We have a time 0, but we need to have the first arrival. And how about departure? No. So about the initialization of an event list for arrival, you should put the first one to the arrival list. And for the departure, no, currently no departure event. Yeah, so of course we need to have the proper setting for event list as well. Sometimes we try to have the height of the arrival and the height of the departure. Even it's null, that's fine. All right. You want to ask this, right?
Yes.
Okay.
Thank you.
Yeah, you're welcome. So, event list, you need to let the event list to start from the right one. That's it. All right. So, this is a question from you, right? Your name?
My name is Kriyama.
Kriyama.
Okay. Yes.
Kriyama. Okay. I will check it later using the line group. Kriyama. Okay, so this is a question from Kriyama. And any other questions else? Next time, if yes, you have the question, you can key in and so that I can notice the question there. Yeah, also it's your possible feedback to me. It's okay. All right, so this is the flow chart. So no further question, then let me go to the next one. Actually, this is the same as the next one, but I provide 2 ways, and sometimes something wrong with the current approach. So I use the hyperlink. I prepare for the backup purpose. And in fact, it seems to be I always use the second one. All right, so discrete event simulation. And in fact, you may have the extended version. The extended version we call event scheduling. And the extended version can be process approaches. So event scheduling, actually, it doesn't mean you have the discrete event. You can have the others. And so that you can have the event scheduling. Oh, all right. Even it's not the discrete event, but this you have the event. First event, second event, and next event. So here, we just want to let you know, possibly you can have the extended version. So the general one, you can call the event scheduling approach like this. Or maybe next one. Of course, we don't really have the detail, but mention these only. Process, because we have the concept of process. So we have some entity. For example, it's a token. Allow the token to go through. So we have a flow. Token flow through the system. You just follow the token to observe. Right? Or someone like, okay, I don't know Hoover. It's me, Hoover, so I come here and go there. So you just notice, oh, it's me, or it's a token. And that one we call it's a process approach. All right, so we may have the others, but currently we don't know. We have the event scheduling approach, or we have the process approach. Still, we get back to let me have the example of a discrete event simulation. So we have a simulation of a single server queuing system. Even for the single server queuing system, we need to define some of the details for the system. First of all, think about this. For the real system, possibly it's bubble shop, and so that you have this example. Perhaps single server, just one server to serve you. So we have arrival, we have a departure. Up now, you know, yes. And actually, just one serve you. So we have the server. Perhaps you go there, but he or she is busy. So we have the status of the server. And you will notice number of customers waiting in queue. Of course, you will have the arrival time. As for next one, most recent just want to draw your attention if you want to determine the next one. Most recent possibly is your candidate. Alright. So you will notice the status of the server, number of customers waiting in queue, and about the arrival time. Most recent one, all the arrival time in queue. All the arrival time in queue should be recorded. Why? Someone like, oh, okay, I'm waiting in queue, but I'm the tail of the queue. You need to keep your arrival time instant, or otherwise you won't have the calculation of waiting time for you. So of course, all the arrival time of the customer should be recorded. Even you can have for the recorded arrival time. You will notice who is the next one. So the most recent one, who is the next one? Who is the next one? Perhaps it's the arrival. That's fine. Or possibly no. It's the service completion. So here we don't really have the most recent arrival event only. Possibly it can be most recent arrival or departure event. So it's possible. So we only have the most recent arrival or departure. Most recent arrival or departure at least exactly is the next one. Right, so in fact it's the next event. Well, after now, next arrival or next departure, we already feel, okay, we can find the next one. Because of some nature of the system. So we can already have for the next one. It's possible. So after now, no worry. Just follow the arrangement of the simulation system or simulation code. We will have the most recent event. Well, we don't have a single server. So just one server. So where we have one server, this one. And we have the line arrival. And here, this is departure. From source site to the current server and depart from the node site. Alright, and then you can see we have a many one, and this one, customer in service. Actually, in service can be included by the, for example, the square. And so that yes, put into the server, so in service. And for the others, they are in queue. Or maybe you have the arriving one, so it's possible. And this one, a departing one. Right, so if so, yes, it's a single server, so one server. Well, because we want to make it feasible. So how to make it feasible? Normally we will have the further assumption. So here we have an assumption. So here we have the assumptions. And previously we didn't know model is possible to collect all the assumptions, right? And even we have an assumption, what it means. We just want to have the feasible assumption so that we have the feasible models. Well, we know the general one, allow to have a arrival. One server serve, and then we have for the departure. Up now, it's really broad because we don't have the further assumption. To have the further assumption, we assume inter-arrival time should be IID random variables. IID possibly should be independently, identically distributed random variable. Or maybe we need to exchange independently and identically. All right. But currently, I think it should be independently, identically distributed random variable, IID. Or maybe you can key in IID, then you can find the definition of IID. So for the arrival IID, what it means IID? Independently. So first arrival, second arrival, they are independent. And the first arrival time, inter-arrival time, second arrival, inter-arrival time, they follow the same distribution. So that's why identical or identically distributed. So IID means for all the possible events, they are independent. And for the time, they come from the same distribution. So IID random variable. And likewise for service time. Okay, time for current customer and time for the next customer. Same. IID service times. And IID service time are independent of the inter-arrival times. And that's one, how I pick the customer to serve. Alright, I have the display. First come. first serve. So first come, first serve, it should be FCFS. Here we have the first in, first out. Same. First come, first serve, or first in, first out. They are the same. So we have a FIFO. And up now, almost all. So we can put all the assumptions, and so they can have the model assumptions. If so, model assumption, then it's okay to have the simulation. And we can have the further assumption. Well, you mention IID only. So how about the distribution? You don't know the detail distribution. So later we will already have the explanation. But up now, it won't be necessary to have explanation immediately. So I won't post explanation here. I just want to let you know single server queuing system. Even here, it's single server queuing system. We still can really have the IID assumptions, or maybe service discipline, so that we have the current single server queuing system. Well, for that one, we can observe. So for example, all right, this is a server. So this is a server, and we have a waiting queue. Served by a server, and then leave. And right now, maybe you don't have any idea why we have this. It's a realization. This is the queue size. Q of t means it's queue size over time. Think about this. How about arrival first one? First one, where to go? Server. So not in queue, right? If you can have the observation, first one, come here, and then enter the server. So how about the queue size? 0. And the next one, because the first customer occupied the server, so second one will be queued. So you can see queue size is 1. And how about next one? Queue size is 2. And why? We have the fourth one. Fourth one says it's departure. So departure occurs leave. So you will drop. So I just draw your attention to this one, specifically this one. Right? So notice the current one, the first one, even we have the first arrival, but it entered the server directly, so it's still 0. And we have a departure, so we will drop. Our story remaining similar to this. Alright, so let me have 1 minute to think about this and discuss with your neighbors about the 2 points. So let me point out again, the current point, first arrival, still we have a 0 queue size, is okay, right? And departure, then we want drop. Alright, so this is the first one. This is the queue length. Alright, this is a queue length. And before I go, let me mention this again. Anyone currently still fail to join our line group? Line. If no, raise your hands. Line group. If so, where to get the slides? You can check line group and you can check notes. So right now you can check notes. Can you see our syllabus? Can you see the entry to the slides? Right? So, of course, you should join our line group, and so that you can have the course materials, including syllabus and slides. And this semester, I already have the directory, and so that you can share the slides. For example, okay, chapter 0, chapter 1, and maybe I have part, so you can visit directly of a part. Am I right? And so that next time, if we have updated slides, then you just visit, or maybe, okay, you are curious about, should we have the new slides? If yes, then you can find it. Alright, so this is the note to you. Note online, so you can check those. And next one, server busy or not. First one, arrival. So occupy the server, busy. Right? As for the others waiting queue, until no servers, until here I cannot point it out, but alright, no customer in service. Is it true? 1, 2, 3. We have 3 in server. Depart 1, 2, 3. So 3 arrival, 3 departure. So 3 minus 3 equal to 0. So it's correct, right? Alright, so I think this is the point. Return to idle, server idle. So we can have a busy, it's 1, and idle, it's 0. So we can have the number 1 busy and the number 0 idle. Alright, that's all. So I think you know, first one, 1. Here, 3 minus 3, so it's 0 again. And here we have for the next arrival, you can check. Alright. About this one, I think it's easy. So that's all. Well, up to now, we may have the observation, queue length. And system utilization. And this one related to B of t. And this one related to Q of t. And B of t, Q of t, how to have the measure? Here, utilization. Utilization, something like, oh, I determine the time from 0 to the current one. And you can pass on the area to have the average level. Alright, so this is the average. And this average we call utilization. Of the current one, is it acceptable? Based on B of t, based on area, then we can have the system utilization. Why this one system utilization? The meaning is, If I provide service, so it's 1. If no, 0. So you can pass on the maybe proportion busy or not. Busy, so this is the average level of busy. So of course it is called the term utilization. About system utilization definition is okay. Even I use the area to let you know the meaning or the definition. Is it okay? It should be okay, right? About the queue size, similar to that one. You can find the average queue size. Right? Same, using area. And here this one, okay, I have the time. For example, the time is t. I determine I want to observe time duration is t. So you can have an area over t. So it's the average queue. Average queue length. And likewise for the previous one. So it's the average value, so you have for the system utilization. Alright, right? So that's why we gotta know the time observation to observe the queue length, to observe the server status. So that based on area, you can have the measure queue length, average queue length, and the utilization. So for the current two measures, definition are okay for all of you, right? All right, so let me go to the last one. So, okay and okay, right? And how about system size? System size here. So system size, it should include the server and the queue. So it's a system size. As for how to have the system size observation, maybe you can re-observe it. For example, for the first one. First customer, even we have 0 queue length, and it should be system size 1. That says, okay, even for the customer in the server, we need to count that one, not exclude it. You need to count, count that one in. So you need to count that one in, so you have the actual one in the server. Alright, so here it should be QS plus the server with the customer. Alright. So you can have the similar way to have the system size and still based on area. As for the other tools, average delay we call it the average queuing delay, and average waiting time we call it the sojourn time. Sojourn time actually is all the time you incur. So it's called the sojourn time or the total waiting time. Well, how to have the measure? For example, for all of you waiting queue, and you can keep when you arrive in and when you depart, so that you will have the delay. For example, queuing delay. Alright, so how to have a delay? Okay, I can ask you. So after getting the service, what's the queuing delay? Delay 1, yours, 2, 3, 4, and the others. So you may have a queuing delay 1, 2, for example, to n, and here over n, so you have the average queuing delay. And likewise, you can have the average waiting time. But what's the difference between the queuing delay and waiting time? Queuing delay says, oh, my arrival time and wait until right before entering the server. Then that's a queuing delay. If the arrival time instant here, okay, I want to go. And the time period here, then you can have the waiting time or sojourn time. So how about to have the average waiting time same? If know your arrival time, here the departure time instant. So I can ask how about your waiting time? 1, 2, 3, 4, and the other. So that you can have the average waiting time for the individual customer. And over the sample size here, and it's a sample size. Alright. And from the concept of a simulation, sample size, can you choose a sample size? Sure, you can determine the sample size. How about 1,000? Even 100, it's okay. But if you want to have a stable result, you should have a really large one, so that you can have the stable measure. So sample size, it will be chosen by you. Likewise for the time. When you will have time, so that you have the time period T. You can pass on simulation is done or not. So that you have the whole simulation time to have the whole observation time. So you can pass on that time to have the time period. And likewise, when to start your simulation. Same, it can be determined by you. For example, you can say, okay, I just want to observe the system over 100 seconds. That's okay, you can have a 100 seconds and then stop. Or maybe you want to count. I just want to serve 100 customers. You don't have the fixed time, it doesn't matter. Oh, after finishing 100 customers, the shop is closed. Then you have the time, right? So to have the time, you can have 2 ways. Time period, or maybe how many events you process, and then you close it. So you have a sample size. You have a time period. So either one, that's okay. And so that you can have the 5 measures here. About the 5 measures, using area, it should be system utilization, queue length, system size using area. For the average waiting time, average delay or average queuing delay, it will use the ensemble average. So we can have a time average, and we can have an ensemble average. So time average says we base on the area, time area to have the time average. Ensemble says we can have samples. Based on the sample, collect all the sample and over the sample size. I use the 2 different ways to have the average. Time average and ensemble average. Alright, so for these terms based on the current patch, likewise that you have 2 minutes to discuss with your neighbors. Of course, after discussion, we take a break for 5 minutes. Alright, before we take a break, let me make sure up now about the 5 possible performance measures using time to have the average. Using in sample, that says using sample to have the average. Any questions? No, right? If no, same. Let us have a 5-minute break. Even we don't have the even duration for the 3 classes, but it's the second time to take a break. Still, 5-minute break. Okay, take a rest.